Section 11.5 is entitled Operating Leverage. But before I get into that, I wanted to go back into 11.4 for a second to show something. This is on page 366. And we see here up at the top that operating cash flow is being represented as the price per unit times minus the variable cost per unit, multiply that by the quantity, subtract fixed costs, subtract depreciation, and then add back depreciation. Well, this is EBIT plus depreciation, but it is ignoring taxes. So from here on down, we're ignoring taxes. So they show that depreciation being subtracted and then added back cancels out. So we have P minus V times Q minus FC. And they drop that down to here. And here is exactly the same as this line. And then they rearrange to show Q, to solve for Q. Q equals fixed cost plus operating cash flow divided by P minus V. And that is what they're referring to as the general expression. So over here, when they talk about the general break-even expression, again without taxes, this is it, and then they just explain why it is that the accounting break-even would substitute depreciation for operating cash flow, and why the cash break-even would get rid of depreciation, and why the net present value equals zero version would use the operating cash flow that gives you a zero net present value. I wouldn't be too concerned about all that. You do need to know these formulas so you can calculate accounting break-even, cash break-even, and financial break-even, at least for homework. I wouldn't expect you to do this one on an exam, though. Now let's get into operating leverage. So operating leverage is the degree to which a firm or project relies on fixed costs. Really, you're talking about the interaction of fixed costs and variable costs. In general, then, a high fixed cost with low variable cost would be high leverage. Low fixed cost with high variable costs would be low operating leverage. So we talked about financial leverage back in Chapter 3, and the idea there was if you have a lot of debt and not that much equity, you have a lot of financial leverage. So if things go well, you do really, really well, but if things go badly, you've got a problem. It's the same way with operating leverage. If you have high fixed costs, that means you have a lot to cover. That is, you have to sell a lot just to cover your fixed costs. If you have low fixed costs, then you don't have to sell as many units to cover those costs. So down here we get into the degree of operating leverage, and that's actually a little calculation. The percentage change in operating cash flow equals degree of operating leverage times percentage change in Q, and that sort of continues on to the next page, but really personally I just like this. Degree of operating leverage is the percentage change in operating cash flow divided by the percentage change in the quantity. That to me is a very clean version of degree of operating leverage. So here we go into an example, and this is a continuation of Wetway, and the fixed costs were 500,000 and the price minus variable was 20,000. So operating cash flow, again not counting taxes, was minus 500 plus 20 times the quantity, and again that's price per unit minus variable cost per unit, and this is fixed costs, so that's our operating cash flow. Now it's different at every level of sales. So if we have 50 boats as our current Q, important, starting with 50 boats as our current quantity. At that level of output, our operating cash flow would be, using this formula, minus 500 plus 20 times the quantity of 50 and 20 times 50 is 1,000, so it would be minus 500 plus 1,000 is 500. That would be our operating cash flow. Okay, now what if the quantity rises by 1 unit to 51? Well, as a percentage change in quantity, back over here, as a percentage change in quantity, that would be 1 divided by 50, or 2%. So we go from 50 units to 51 units. That's an increase of 2%. Our operating cash flow, what would happen to it? Well, it would go up by 20. Why? Because we're selling one more unit, and our contribution margin per unit is 20,000, so we go from 500 up to 520 thousandths. Now, what percentage change is that? Well, it's 20,000 divided by 50,000. Well, what's 20,000? Sorry, 20,000 divided by 500,000. Well, what's 20,000 divided by 500,000? 4%. So we have in the numerator 4%, in the denominator 2%. 4% divided by 2% is 2. Now, following through using their preferred formula, the degree of operating leverage is equal to 1 plus fixed costs over operating cash flow. So here it is down here, 1 plus fixed costs over operating cash flow. It's just repeated. And then we plug in the numbers. Fixed cost is 500, and the operating cash flow also 500. So 500 over 500 is 1. 1 plus 1 is 2. Our degree of operating leverage is 2, which is just what we calculated before. This goes into, this footnote is referred to up here, and this goes into a whole derivation of how they get this, this formula. Not that important to me because I don't really prefer that formula. I just prefer this. But note that degree of operating leverage is going to change for every level of Q. Regardless of what the Q, if you go to a different, calculated a different quantity, you're going to end up with a different degree of operating leverage. Now, they show a little example going back to Wetway again. They say, well, at 85 boats, what would the degree of operating leverage be? Well, fixed cost divided by operating cash flow. Operating cash flow was $1,200,000, and fixed costs were $500,000. So 1 plus 500,000 over $1,200,000 is 1.42. Now they look at the net present value, which was calculated as 88,735, and an accounting break-even was 60. So that's in the prior section. What if? What if they decided to subcontract part of it? And now the investment would not be $3,500,000. Instead, it would be $3,200,000. And the fixed costs would not be $500,000. They'd be $180,000. But the variable costs would rise from $20,000 up to $25,000. And that means that the contribution margin per unit would not be 20, it would be 15. So how do we evaluate this option? And what they show, they don't show the calculation, but they show the answer is the NPV for 85 units under this new version would be 74,720, not 88,735. So the lower degree of operating leverage by having lower fixed costs and higher variable costs, that lower degree of operating leverage, which is calculated to be 1.16, would give us a lower NPV. On the other hand, it would give us a lower accounting break-even. So, which one would you choose? Well, you kind of pay your money and you take your choice. And that is actually the ringtone on my phone, and my wife is calling. But that was all I had to say anyway.